Hello everyone. Today I am going to explain about introduction to probability. Now what is mean by probability? What are the definitions involved? How many examples? Everything I will tell you in detail. Now the theory of probability is one of the most useful and interesting branches of modern mathematics. Now this is very most important, useful, interesting branches of modern mathematics. Now before going to start the probability, how the word probability came, I will tell you. If an experiment is repeated under essentially identical conditions, whatever the experiment, whatever you do, that one is experiment. If you think, if an experiment is repeated under essentially identical conditions, we can observe two things. What are the two things? The result is, we can observe two things. If you do one experiment under essentially identical conditions, we can observe. Now the two things are the result is unique or certain. Definitely if you do this experiment, you will get such type of result. Like that, before itself the answer or the solution you can predict. That is the first case. And the second case, the result is not unique. The result is not unique, but it may be any one of the several possible outcomes. Now, if you do an experiment under essentially identical conditions, we can observe two things. The first thing is the result is unique and certain. The second thing is the result is not unique, but it may be any one of the several possible outcomes. The example of the first one I will give you. For the first case, the example I will give you. Now, if you do one experiment, if you do a physics experiment, pressure into volume is equal to, if you do one experiment, this is physics experiment, pressure into volume, if you do any time under essentially identical conditions, if you do, whenever you do the experiment, you will get the result as a constant, provided the temperature remains same. If you provide the temperature same, whenever you do the experiment, pressure into volume is equal to constant, you will get. Now that means whenever you do this experiment, such type of experiment, you can predict the result before itself. You can predict the result. If you do like this, you will get the answer in this way. If you do like this, you will get the solution, or whatever the result, you will get like such type of result. You can predict the answer, that it is certain result. You will get certain result. You will get such type of result. You can predict. That's why such type of phenomena is called the result is unique and certain. We can before itself, for example, pressure into volume is equal to, whenever you do this experiment, you will get the answer as a constant. Now, provided the temperature is same, such type of phenomena is called deterministic phenomena. First one example is pressure into volume is equal to constant. Such type of phenomena is called deterministic phenomena. And I will tell you the second one example. Example of the second one. The result is not unique, but it may be any one of the several possible outcomes. The example of this one I will give you. Now, if you toss a coin, we cannot sure whether a head or a tail will get. We cannot sure. You may get, if you toss a coin, we may get either head or tail. We cannot sure. We cannot predict before itself. We will get a head or we will get a tail, like that. We cannot sure whether a head or tail turns up. Like that we cannot sure. Such type of phenomena. In the same way, one more example. If you see, if you throw a die, you may get, now the die is having 6 faces, it is in cubical shape. You may get either 1, or you may get either 2, you may get either 3. We cannot sure whether we will get definitely 1 or we will get definitely 5, like that. It may be any one of the several possible outcomes. That may be one, you may get either 1 or 2 or 3 or 4 or 5 or 6, like that. Such examples are these: tossing a coin, tossing a coin. We cannot sure, we may get either head or tail. In the same way, you can take the dice example also. Such type of phenomena, second one, such type of phenomena is called probabilistic phenomena. Now the word probability came like that. The such type of phenomena is called which type of phenomena? The result is not unique. It may be any one of the several possible outcomes. Example is tossing a coin, throwing a die, or such type of examples. You can take any number of examples. Now such type of phenomena is called probabilistic phenomena. Now before going to explain the definition of probability, few definitions first I will tell you. Finally I will tell you the definition of probability. Now random experiment. What is a random experiment? Now what is a random experiment? First I will tell you. Now if an experiment is conducted any number of times under essentially identical conditions, you will get a set of possible outcomes associated with it. If you do one experiment under essentially identical conditions, you will get a set of possible outcomes associated with it. Now, if the result is not unique and it may be any one of the several possible outcomes, then such type of experiment is called random experiment or a trial. The outcomes, whatever the outcomes are, they are known as elementary events. The outcomes are known as elementary events, and the set of outcomes is called an event. Like that, what is meant by elementary events? The outcomes are known as elementary events. The set of outcomes are called an event. A set of outcomes is known as an event. Example of this one is, if you throw one die, we don't know throwing a die is a random experiment. We don't know the result, we cannot predict the result. It may be any one of the possible outcomes. How many possible outcomes are there? If you throw a die, you may get either 1 or 2 or 3 or 4 or 5 or 6. If you throw one die, you have 6 possible outcomes are there. You may get either 1 or 2, like that. Now all possible outcomes are called elementary events. A set of outcomes are called an event, I told you. Now if you throw one die, what is the probability of getting an even number? If they ask one question like this, getting an even number. Now if you throw a die, you may get either 1, 2, 3, 4, 5, 6. 6 possible outcomes are there. 1, 2, 3, faced 1, 2, 3, 4, 5, 6 possible outcomes are there. How many even numbers are there? 2, 4, 6, 2, 3. Now what is the probability of getting an even number? Total possible outcomes are 6. Even number, how many are there? 1, 2, 3. 3 by 6 will become the answer. Set of outcomes. 2, 4, 6 is a set of outcomes is called, these are all possible outcomes are elementary events. A set of 2, 4, 6 is a set of even numbers. It is a set of outcomes, a possible outcome. Set of outcomes is called an event. Now what is the difference between elementary event and event? All possible outcomes are called elementary events. A set of outcomes are called an event. Set means getting a even number is an event. Getting an odd number is an event. 1, 3, 5 is the odd number. Getting an odd number means how many are the set is 1, 3, 5 is an event. Like that. This is the about elementary event and event. Now next one is example of that one is like this. Now next one is equally likely events. What is meant by equally likely events? Events are said to be equally likely. When will you say the events are equally likely? Said to be equally likely, then there is no reason to expect any one of them rather than of the other. Equally likely events. Events are said to be equally likely. There is no reason to expect any one of them rather than of the other. What is the meaning of this? If you, for example, if you toss a coin, we cannot expect, there is no reason to expect we will get a head only, we will get a tail only, like that. There is no reason to expect any one of them rather than of the other than tail, we will get a definitely head only. We cannot expect, there is no reason to expect any one of the, like that. Now if you toss a coin, in the same way, if you throw a die, there is no reason to expect we will get 5 only. There is no reason to expect like that. We will get only 4 only. There is no reason to expect any one of them rather than of the other than 5 we will get 4 only. Like that we can, there is no reason to expect any one of them rather than of the other. In the same way you can see the example, when a die is thrown, elementary events getting a number 1, 2, either 1 you may get either 1 or 2 or 3 or 4 or 5 or 6 or all are equally likely. Equal chances are there to get either 1 or 2 or 3 or 4 or 5 or 6. There is no reason to expect any one of them rather than of the other. Throwing a die. The next one is exhaustive events. Exhaustive events. All possible outcomes are called in a trial. All possible outcomes in any trial are known as exhaustive events. If you toss a coin, you will, how many exhaustive events are there? 2 exhaustive events are there, because if you toss a coin we may get either head or tail. Total possible outcomes are 2. That's why all possible outcomes are called exhaustive events. If you throw a die, the total number of exhaustive events are 6, because the possible outcomes are 6. If you throw a die, either 1 or 2, 3, 4, 5, 6 we will get it. Like, that's why all possible outcomes are called exhaustive events. The next one is mutually exclusive events. Events are said to be mutually exclusive. When will you say the events are mutually exclusive? Events are said to be mutually exclusive if happening of one event prevents the happening of any other event in a trial. Happening of one event prevents the happening of any another event in the trial. Such type of events are called mutually exclusive events. Now, example of this one is, if you toss a coin, either head or tail we will get, but both cannot, we won't get both tail and head at a time. We have got head means getting tail is turned off. Now that means happening of one event mutually exclusive. When will you say it is the events are mutually exclusive? Happening of one event. If happening of one event prevents the happening of the event. Head, we have got head means getting tail is ruled out. If you throw a die, we have got 5. If you throw a die, we have got 5 means getting 1, 2, 3, 4 and 6 ruled out. Happening of one event prevents the happening of the other. We can take any example, either simple examples I am telling you, tossing a coin or throwing a die, like that. The next one is, this is the about mutually exclusive. Happening of, when will you say the events are mutually exclusive? Happening of one event prevents the happening of the another event in a trial is called mutually exclusive events. Now favorable events. What is mean by favorable? The number of outcomes favorable to an event in an experiment. The number of outcomes favorable to an event in that experiment is called favorable events. Now, favorable events means, see, if you toss a coin, what is the probability of getting even number. For example, what is the probability of getting even number? How many are there favorable? There are 2, 3, 2, 4, 6. Favorable events, how many are there? 1, 2, 3. 3 are there. 3 numbers are there. Therefore, 3 by the favorable events are the number of outcomes favorable to an event. Favorable to an event. What is the probability of getting an even number? I told you, na? What is the favorable cases to get an even number? Favorable cases, how many are there to get an even number? 2, 4, 6. Therefore, 1, 2, 3. 3. Thereby the total number of elementary events. I will tell you the definition of probability at the time you can understand. Now, the next one is independent events. Now, independence, how to define independent event? This is suitable for 2 or more events. Now, one by one, if you do an experiment like that, it is suitable for 2 or 3 events like that. Now, independent, when will you say the events are independent? 2 or more events. 2 or more events are considered to be independent. When will you say 2 or more events are said to be an independent events? If the occurrence or non-occurrence of any event, occurrence or non-occurrence of any event does not affect the occurrence or non-occurrence of the other. Now, happening or non-happening or occurrence or non-occurrence of any event does not affect the occurrence or non-occurrence of the other. Example is, for example, simple example I will tell you. For example, if a coin is thrown twice, I tossed a coin twice, 2 times. I tossed a coin 2 times. The result of the second time I have got, whatever the second time I have got, the second throw is no way affected by the result of the first throw. Second time I have got whatever the answer, second time answer does not, second time result no way affected by the result of the first time we have got head, that's why second time also head we have got, or first time we have got tail, that's why we have got head, like that. The events are said to be independent. Independent if the occurrence or non-occurrence, happening of non-happening of an event does not affect the happening or non-happening of the other events. Now, like that examples we can take. If a coin is thrown twice, 2 times, the result of the second throw no way affected by the result of the first throw. Such type of events are called independent events. Now, finally we will go to the probability definition. The probability definition. Probability definition. Now, one experiment is conducted under essentially identical condition. There are small n number of, there are n number of small n number of, there are n number of equally likely, mutually exclusive and exhaustive events are there. N number of equally likely, mutually exclusive and exhaustive events are there. There are m number of favorable events are there. M number of favorable events are there. Then the probability of happening of an event. Then the probability of happening of an event, E, is denoted by P of E, probability of E, P of E, probability of happening of an event is denoted by P of E is equal to M by N. P of E, probability of happening of an event, is denoted by P of E and defined as M by N. What is M? M is, there are M number of favorable events are there. There are N number of mutually exclusive, exhaustive and equally likely events are there. Then probability of happening of an event is denoted by P of E and is defined as M by N. Now, probability of happening of an event is denoted by P of E is equal to M by N. M favorable events by M number of favorable events by N number of exhaustive events are there. Now, probability of happening of an event is denoted by P of E. In the same way, probability of non-happening of an event is denoted by P of E bar. Or probability of non-happening of an event, or probability of non-occurrence. This is probability of occurrence, probability of success, P of E. Probability of success, probability of happening of an event, probability of happening of an event, probability of occurrence, all are same. Probability of non-happening of an event, probability of failure, probability of non-occurrence, remember, is equal to P of E is equal to 1 minus P of E. Therefore, P of E plus P of E bar is equal to P of E plus P of E bar is equal to 1. Probability of happening of an event is denoted by P of E. P of probability of non-occurrence of non-happening of an event is denoted by P of E bar. P of E bar is equal to 1 minus E. P of E plus P of E bar is always 1. Always remember, probability of happening of an event, probability of occurrence, probability of success always lies between 0 and 1. In the same way, probability of non-happening of an event or probability of failure is always lies between 0 and 1. That means whatever the problem in probability, if you do, you will get the answers in between 0 and 1. You won't get a such type of another type of answers. Now, probability of happening of an event is always lies between 0 and 1. Non-happening of an event also lies between 0 and 1. Now, if you get P of E is equal to 1, then it is called sure event or certain event. If you get P of E is equal to 1, it is called sure, S-U-R-E, sure event or certain event. If you get a P of E is equal to 0, if you get P of E is equal to 0, then event is called impossible event. Why? Because P of E is always lies between 0 and 1. P of E bar is also lies between 0 and 1. For suppose if you get P of E is equal to 1, it is called sure event or certain event. If P of E is equal to 0, if you get for suppose, it is called impossible event. The remaining in the next class we will see.